What's up, coders? Good morning, good afternoon, and good evening. Today, we're back with another Leetcode problem. Number 242, valid anagram. We're given two strings here, s and t. Our job is to write a function that can determine whether t is an anagram of s. An anagram is basically a rearrangement of the letters in s. Right off the bat, we can write a base case that checks whether the lengths of the two strings are equal. If they're not equal, we know that there's no chance t is an anagram of s. Otherwise, we move on to step 2 of this algorithm. In step 2, we use a hash table to keep track of the frequencies of each letter. We're going to be scanning through both strings and updating the frequencies along the way. Let's see this in action. On the s side, we see that there's an a. That means it has to be matched by a character in the t string. So therefore, we're going to increment the frequency of a in the hash table. On the t side, we see that there's an n. Therefore, we're going to be using the n. It's going to be matched. We're going to decrement the n to -1. On the s side, we see that there's an n. So there's a spot for it now. We can increment it back to 0. On the t side, we see that there's an a. We're going to be using that a. On the s side, we see that there's an a. We're going to be providing a spot for that a. And then on the t side, we see that there's a g. We're going to be using that g. And then on the s side, we see that there's a g, so we're going to increment to 0. And then on the t side, we see that there's an a. We're going to decrement to 0. And then the rest is just our an. We're going to increment, decrement, which means everything stays at 0. At the end of this process, we know that all the letters have taken on a frequency of 0. This is good because that means that all the letters in both strings have been perfectly matched. However, if there is a value in the hash table that is either positive or negative, basically non-zero, then that means we do not have an anagram. We can return false. This is because we would have a surplus or a deficit of characters on the t side. Now, the one way we can make this faster is to use an array. According to the constraints of this problem, we only have lowercase English letters. That means we can simulate a hash table by using an array of size 26. This implementation is going to be using a hash map because it's more generalizable, but the array implementation is basically the same. With that being said, let's go to the coding portion of this problem. All right, with the coding portion, let's start with our base case. We're going to say if the length of s does not equal the length of t, then we're going to return false right away. Otherwise, we're moving on to step 2. Create a counts hash table, and then we enter our for loop. For I in range length of s, we're going to go and do the exact updating of frequencies we did in the conceptual section. Counts of s of I plus equals 1 for the s string, counts of t of I minus equals 1 for the t string. And then we want to go through each value in the counts dictionary. For a count in counts.values, if count does not equal 0, we return false immediately. Otherwise, we can return true. Let's see if this works. All right, we have an accepted solution here. Before we go, let's go through time and space. Time is going to be big O of s because we're just going to be iterating through the s string. Space is going to be big O of 1 because we know that we're not going to be dealing with more than lowercase English letters, so our dictionary is not going to be bloated with a bunch of characters. And we don't use any other extra space otherwise. All right, that is it for this problem. If you liked it, please like, comment, and subscribe. And I will see you in the next one. Bye.